So we're done already on the part where we do the first law and the second law of thermodynamics. So what we're going to do today is discuss the remaining part of the what we call the module 5, and then later on I'll go back with module 4. So during the weekend you can concentrate on the topic that will be covered on the exam, and then we'll move on Tuesday with module 6. Okay, and then maybe have a review on Thursday before the exam. So just to let you know, you have access to some of the worksheet like this one. So if you open it, nakikita nyo ba? Okay, you can solve some problem that can help you preparing yourself or practicing yourself. Just don't rely, please don't rely on what we call discussing. Okay? Baka kasi mamaya, ang ini-study nyo lang yung binibigay kong materials. Okay, there are other materials that is given here. I told you, you are lucky, okay, because aside from the minimum material that are given to you here in the module, you have access to what we call my recorded lecture. And then we still have a time to go over some of the material in addition to those recorded lecture that I have. And as you could see, it is of different sources. Okay, so try to go over this, practice during the weekend. Okay, because I think there's a question about this in your exam. Now, the one that we're going to talk about today is the so-called phase changes. So when we're talking about phase changes, these are the chemical changes where there is transformation of what? From one phase to another. So this is just a physical change. Okay, so this is not really a chemical reaction, but similar to chemical reaction, these physical changes that we have, it also involves energy. So if you apply energy, okay, so you can remove, or you could say overcome, the intermolecular forces of attraction that hold the molecules together. Just like when ice is melted, it becomes liquid, and when you heat it further, okay, your liquid becomes gas. So the main reason why they undergo these physical changes is you're overcoming the intermolecular forces that hold them together. So if you're going to look more about this one, so there's a material that you have here. Usually the material is connected in what? The LibreText. Okay, so if you have to discuss the energy accompanying the physical changes, so this is what we look at. Okay, so as you're going to look at here, solid, liquid, and gas. As you increase the energy, you increase the transition. So increasing the energy means applying energy to it. Okay, so the amount of heat that is needed to convert a solid phase into a liquid phase is what we call the heat of fusion. Okay, now the amount of heat that is needed to evaporate or vaporize a liquid phase to the gas phase, that is what we call heat of vaporization. Now, if the transition is from solid directly to gas without passing the liquid phase, okay, that is heat of sublimation. So how do you relate heat of sublimation with heat of vaporization and heat of fusion? Anyone? Paano mo sila i-relate yung tatlo? How is the relationship of this with regards to this? And what we call this. So this is just an application of what we call Hess law. Okay, because you might say this is the one where you involve what? Heat of vaporization, H2O, producing liquid to produce gas. And then this one, H2O, producing solid, solid. You apply heat, you produce liquid. So if you add the two, so what you have? Oh, it's the gas. And this is what we call the heat of sublimation. And from this, you could say that you just add heat of vaporization plus heat of fusion. So it's just an application of the topic that we have just learned, Hess law. Okay? So heat of sublimation is always higher than heat of fusion. And also, what do you think is the relationship between these two? What's the relationship between these two? Although it's not clear in your handout, they're almost what we call equal, but the truth is heat of vaporization is always higher than heat of fusion. Because in the heat of fusion, you're just overcoming the intermolecular forces of attraction. The one that breaks down, okay, the lattice, if you have a molecular solid, okay. Now for the heat of vaporization, you're breaking down the intermolecular forces of attraction. In the heat of fusion, you break it, but the resulting what we call condition, it still has what we call an intermolecular forces of attraction. They're just far from one another, but they're still attractive forces. But in the heat of vaporization, you break apart because they will have a gas, and later on when we go to the gas, okay, there's no more attractive forces that hold the molecules together. So it's always that this value is greater than that one. Now, the reverse of that, okay, so if you're going to cool, so anytime you cool, you're removing heat, you're removing the energy. So it's just the reverse of this, what we call process. So it's not heat of condensation, okay? So we could just say the condensation process, if you want to condense your gas to liquid, you're going to remove some energy on it. Okay. And again, that's just the reverse of this one. So those are the different, we could say, physical changes. So if you're asked what is heat of fusion, heat of sublimation, heat of vaporization, this is just, we could say, the amount of energy needed to convert, okay, the solid to liquid, the solid to gas without passing the liquid phase, the liquid to gas. Now, heat of solidification, that's the reverse of fusion. The amount of energy needed for your sample to be frozen. Heat of deposition, the reverse of sublimation, and then the heat of condensation. Now, in some instances, we have the so-called supercooled liquid and superheat liquid. Okay? So usually this represent what? Okay? You can see the supercooled liquid or the superheated liquid in these so-called phase changes. And the phase changes that we have, ito yung tinatawag nating heating curve or what we call cooling curve. So if you're going to look at the values here, so heat of fusion, boiling point, heat of vaporization. So look at the values that you have here, right? So the heat of vaporization is always higher than the heat of fusion. Make sense? Tama ba?
Yes po.
Okay. Those are the type of question that they may ask in multiple choice question, or we could say true or false question. And if you're going to read it together here, the enthalpy of vaporization itself is much greater than, because it takes more energy to completely separate the molecules. Okay, than to enable them only to move past one another freely. Now, the heating curve and the cooling curve, this is what we call the temperature curve. So in the temperature curve, you're adding heat or energy, or you're removing heat or energy. So if you're adding heat, okay, with time, okay, you have what we call the heating curve. So if you're going to look at the heating curve, this is what you have, the time and the temperature. So the longer the time that you're applying energy, the more energy that you apply there, okay? So the idea there is you're breaking the IMFA that you have. So if you're going to look at this heating curve, so from point A to point B, okay, this is solid. The phase there is solid. Now what is changing here from A to B? Anyone? Because if I'm not mistaken, you're asked to do something here. So A to B there, if you're asked what the state, everything there is solid. Now, is the temperature constant? Yes or no?
No po.
Anyone? Okay. The temperature is not constant. Okay. Now, is there a phase change? Yes or no? At this A and B. May phase change ba dito from A to B? The answer is no. Kasi solid siya eh. Do you follow?
Yes po, sir.
Okay. Now, once you reach this one, what happened here? This is what we call your melting point. Now, at this case, what happened to your temperature? Is it constant at this phase? Okay. Yes, it is constant. Okay.
Yes po.
It is constant. Now, is there a phase change there?
Yes po.
The answer is yes, because at this point, your solid starts to melt. So we could say at this phase, there's a coexistence of solid and liquid phase. Okay, so solid and liquid coexist here until such time that when you reach this point, you only have what? Ano na lang yung phase mo? Pag dumating ka dito, you only what we call liquid. And in that case, it starts to increase the temperature again. So when the temperature increase there, it's all liquid, right? So this point here, C to D, if you're going to fill it up, it's all liquid. Is the temperature constant? The answer is
No po.
no, because you see here, it's changing. Okay. Is there a phase change? The answer is
No po.
no, because they are in liquid form. But once you reach this one, which we can call the boiling point, so the temperature becomes constant, and at the same time, there's the coexistence of the liquid and the gas phase. So the liquid starts to be converted into gas. Okay? Until such time that there's no more liquid, so the temperature starts to go up again because it is now all gas. So kaya nyo nang sagutin dito? If meron kayong problem sa exam na ganyan?
Siguro.
Kaya wala siguro. Gusto ko. Sigurado. Okay? Now, you can always read this material. Okay? Because as you could see, I just get it from the links here. It's been available there. Kaya nga mamaya magtatanong ako some question. Now, how do we relate the phase change in calorimetry? So what do we think the relationship of heat to the amount of the material? Ano yung sabi natin noon, yung tinatawag nating enthalpy, di ba? Enthalpy is what? Extensive or intensive property? Ano siya? X or in? Okay, so it's an extensive property. So that means it depends on the amount. Okay? So ganun din yung relationship ng calorimetry as phase changes. Pag mas marami yung amount ng material mo, mas marami yung energy. Okay? So let's say meron kang 1 gram ng ice compare sa, let's say, 100 grams of ice. Pareho ba yung amount ng energy ang i-apply natin para ma-melt siya? Okay? Usually hindi. Saan mas madami? Yung 100 grams. Okay? So, ang mangyayari dito, if you're going to relate here, so there is a science or field that measure, okay, this type of reaction or the way that determining how much amount of heat do you need. Let's say to convert from one phase to another. Okay? So ang usually na ginagamit dyan is Q equals to M times specific heat times delta T. In some book, they simplify this. This is just what? Q equals to MC delta T. In some, ganito. Okay? So, ano yung constant dyan? Usually, yung constant dyan ay specific heat. So, that is dependent on a given material. So, merong constant value, let's say, for a given material. Okay? So, ang nagbabago dyan, ito, tsaka ito. So, if you're going to look at it, the higher the mass, the higher the energy. The higher the change in temperature, the higher the energy. So, dyan siya directly na naapektuhan. Yung C, dependent yan doon sa given material. Okay? So, yung specific heat na mini-mention natin dito, this is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius without phase change. Now, kapag mayroong phase change, anong gagawin natin? Papasok diyan kung ano man yung heat of process. So, kapag melting heat of fusion, okay? Kapag evaporation heat of vaporization. And the way that we do on it is usually yung heat of vaporization, yung value niya is moles per, joules per moles. So we just multiply it with the amount of heat na i-convert natin sa moles. Okay? So kapag walang phase change ito, yung magde-determine ng heat, kapag merong phase change, kailangan mo i-take ito into consideration. And there's some example that we have here. Tadam! Nakita niyo na ba to? Okay? So, anong ibig sabihin niya kung hindi niyo nakita? So, pakita ko lang sa inyo saan ko kinuha yan. Ha? So, tatanggalin ko ulit. So, pupunta ako dyan. So, i-click ko. So, yan yung lalabas. Kita nyo yung may oble?
Yes po.
Yes, sir.
Yes po.
Okay? So first time yun nakita to? Your answer gives me an idea kung anong klaseng student kayo. Because there are links that you have there in the modules. Okay? So here, you may be asked question like this. So you are asked to calculate the amount of heat in joules. Okay? Required to convert 180 gram at 10 degrees Celsius to steam at 105 degrees Celsius. So if we're going to solve a problem like this, so ilalagay natin yung given. Yung mass ay 180 gram agua. Okay? And then, meron tayong 4.18 at 2.03. Baliktad data. 4.18 and steam. Specific heat pala, hindi heat. So that's what we call the C. Per joules times gram. And then the other one is 2.03. But kailangan mo pa rin dito ng heat of vaporization. 2.26 times 10 to the 3. .26 joules per grams. So hindi siya moles, kundi grams. So ano yung temp? Although the solution is given there, I just want to show you how it's being done. 10 degrees Celsius to 105. So ano yung mga transition na dadaanan niya? So you have water. So at 10 degrees Celsius, ano yung ano niya? Ano yung phase niya? At 10 degrees Celsius.
Liquid po.
So that's liquid. Okay? So that's from 10. Tapos papunta siya sa ano? 105 ba agad? 100 degrees Celsius. So, ang gagamitin mo dyan ay ano? Yung Q equals to MC delta T. So that's your Q1. Okay? So once you have there in your Q1, ano yung Q2 mo? 100 degrees Celsius din, but this is what? Heat of vaporization. So yung Q mo is equals to the mass times the delta H. Now, I use the mass kasi mass naman yung given dyan. Tapos after that, ano yung Q3 mo? From 100 to 105. And here, that's QMC delta T. So yung C mo dito ay yung 2.03. Analyze. So, ano yung total heat? Q1 plus Q2 plus Q3. So ito yung Q1 mo, ito yung Q2, ito yung Q3. And I think that's where they provided you with the solve. Ayan. Ano ba nangyari dito? May napindot ata ako. Pindutin ko na lang ulit. So, ibabalik ko ulit dito sa so if you're going to look at those, yung ginawa ko, ito din yun. So 180 grams of water warming from 10 to 100 degrees Celsius. And then at 100 degrees Celsius, you boil it. Okay. And then after 100 degrees Celsius, when it becomes gas, you warm it again to 105. So if you're going to look at the step here, so mass times specific heat times delta T, so ilalagay ko yun, value doon, and this is what you get. Now, in the second step, since yung heat of vaporization given siya in mass, so we can just multiply it with 180 mass. So if it's given in moles, kung given ka ng mass, i-convert mo yun sa moles. May problema ba converting from mass to moles? Class? Kaya nyo ba mag-convert from mass to moles? Hello?
Kaya naman po siguro.
Hindi pwedeng
Yes
siguro.
po, sir. Kaya po. Yes po.
Kasi kung siguro kayo, yung magiging test score ninyo, siguro din. How do you get from mass to moles? Anyone? Paano yung calculation? So let's say kung ang given dito ay moles. So how do you convert yung 180 grams to moles? Anyone? You multiply it with 1 over 18. Ano yung 18? What is 18?
Grams po.
Ha?
Grams po.
Anong value ng 18?
Molar mass.
Okay,
Grams
that's the
po.
molar
Molar
mass.
mass po ng water, sir.
So that's 1 mole over 18 grams. So if you're going to do that thing, you cancel the grams, you have the moles. Okay? So once you have that, nasa na yan? Balik-balik ulit, balik-balik. So I told you, depende kung ano dito. Sometimes yung delta H of vaporization is given usually in joules per moles. But happen, sa problem, if you're going to look at it, it's given as joules per gram. Okay? So that's the corresponding mass when you convert your 180 gram from liquid to gas. And then the third step, using that thing, okay? So, iba na yung specific heat dito kasi steam na siya kaysa doon sa water. Okay? So, at the end, you're going to add everything. So, yung total heat na ginamit mo yan. Okay? Now, you have to really be careful kung ano yung ginibigay na value. Now, you can do the same thing with the next example here. 50 grams of ice at negative 12 degrees Celsius to convert to water at 20 degrees Celsius. So again, this is made up of 3 steps. Okay, from negative 12 to 0. And then at 0, you have the heat of fusion. And again, it's joules per gram. Okay, and then once it becomes water. So the transition from 0 to 20. So the heat that you need to warm from -12 to 0 degrees Celsius, the heat that you need to dissolve or to melt 50 grams of water and 50 grams of ice to water, and the heat that you need to convert the 50 grams of your water from 0 degrees Celsius to 20 degrees Celsius. So the same thing as we have. Analyze. It's there. The material is there. Okay. Because I'm trying to, what we call, ask myself, bakit ang baba ng score nyo sa exam? If you are a UP student, if you're given everything, you should be able to answer it, especially if it's what? Open notes. But the problem, I think, naisip niyo na open notes, hindi na kayo mag-aaral kasi you will have the resources. Okay? So I want you to try doing the materials problem here because most likely ganyan yung question ninyo sa exam 2. So if you're going to solve this one, just as a guide to you, hindi ko isa-solve talaga. I'm just going to show you kung paano yung map with a problem like that. So if you're going to look at the given there in the SAQ problem, you have what? 120 gram ice. So it started at -7 degrees Celsius. Okay. And you are asked how much heat is needed to convert that to 80 degrees Celsius. So we could say the Q1, that is to convert for the energy needed from -7 to 0. So Q1 is just equals to 120. And then the specific heat, I think we can use the one that we have for water. Doon sa previous problem natin, which is 4.18. Oops. And then we have what? Delta T. So that is from 0 to -7. So that's what 7 plus 7. So that's Q1. Okay. And then you have 120 grams here of your ice. What happened? It becomes 120 grams of water. So that's Q2, which is equals to 120 times the heat of vaporization that is given there, which is equals to what? Ano yung heat of vaporization dun sa problem?
$2.26 po, sir.
2.26 ba yun? Hindi ata 2.26. 2.26 ba yun sa water? Heat of fusion is 334 joules per gram. Kuha nyo? So if you're going to look at the problem, so the thing is, you need this information to be supplied to you or else hindi mo siya masosolve. So if we're going to do this thing here, oops, nawala. I'm trying to share. Nasaan na yun? So if you're going to look at things here, so yun yung kailangan mo, yung 334 joules per gram. I think what you use there is the first one, which is heat of vaporization, not heat of fusion. Okay? Clear ba tayo doon?
Yes po, sir.
Okay? So if we're going to, nasaan na yung aking pang-share? So if we're going to continue, so 120 times 334 joules per grams. So you have that the gram. So yan yung Q2. And then the next one, okay, so that's from 0 degrees Celsius, papunta, ano yung final temp? Based on sa problem? 80 degrees Celsius. So the Q2 here, okay, so you have 120 times. So, ilan nga natin? 4.18 ba yun sa yellow? Baka kasi mali yung binigay ko sa inyo. Yes, mali nga. So in specific heat of ice is what? 2.09. So alin yung, saan ako nagkamali dito? Ito, no? Yan 4.18 dito. You follow? And then you multiply it with 80 minus 0, which is just 80. Now, just to convince you na mali ako, okay? So sa water dito, binigay yung specific heat ng ice as 2.09 and specific heat of water as 4.18. That's why I need to change the value that I used initially here because hindi naman siya yung amount nung sa ice eh. So dito ice pa siya. So whatever happened here, so you add Q1 plus Q2 plus Q3. And the answer should be similar doon sa nasa answer key nyo dito, which is 8.2 times 10 to the 4 joules. Tanong. May tanong? Before we go to phase diagram. So I'm just using the module. Okay, baka sabihin nyo, saan kaya nakuha ni Sir yung mga materials? No, I just using the module. So in the phase diagram, so this is another way for you to present the phase of a given material at different temperature and pressure. Okay? So in the phase diagram, marami kang makikita dito. So just to give you an idea what it is, I click that one. So kay LibreText uli kayo mapapaano dyan. So when you're talking about the phase diagram, this is just a graphical representation of the physical states of a substance at a given temperature and pressure. So temperature would be in the x-axis, pressure would be in the y-axis. So if we're going to what we call draw it, it will be like this. And to give you a specific example, this is how a phase diagram looks like. There. So usually ito lang. Pag inano mo, yan. Phase diagram. Now what information you can get in the phase diagram? Okay, so kung i-drawing ko yung phase diagram, So usually, let's say ganito. Kita nyo ba yung ano, window? So we have here the solid, the liquid, and the gas. So what can you say about that? So this point here, this line here is a boundary between the solid and the gas. This line here is the boundary of the solid and the liquid. This boundary here, that's the liquid and the gas. So this point here is what? Anong tawag natin yan sa point na yan, which I label A? Anyone? So yan yung tinatawag na,
Triple point po, sir.
yan yung tinatawag na triple point. Hindi yan melting point. Okay? So if you're going to look at this point here that I put as A, it's made up of what? Solid, liquid, and gas. That's why we call it the triple point. Clear ba?
Yes po.
Okay? So if you're going to look at this, yung triple point na makikita natin dyan, dito tayo sa ano, phase diagram. Ito yun. Now, possible question about it, meron kayong ibibigay na let's say ganito, tapos i-identify sa inyo, what is A? What are the phase or phases you can find in A? Okay? So yan yung tinatawag nating triple point. Okay? Now, ano pa yung nakalagay doon? Yung tinatawag na critical point. So saan yung critical point? Ito yung critical point na yan. So sa critical point na yan, anumang taas ng pressure mo or temperature, okay, hindi mo siya ma-liquefy. So yung form ng material mo is yung tinatawag nating supercritical fluid. So when it is in a supercritical fluid, okay, it's neither a gas or a liquid. That's what we call another form, and you take advantage of this property. Are you familiar yung dry cleaning? Paano nagwo-work yung dry cleaning? Bakit tawag sa kanya dry cleaning? Kasi walang tubig. Tama? Ano involved sa dry cleaning? Anyone? So you're not answering, it's only a confirmation na hindi nyo pinanood yung lecture ko. Okay? PERC, perchloroethylene. So how do it do it cleaning? So ilalagay mo t-shirt doon sa supercritical fluid. So pag nag-pass through yung material, yung cleaning reagent na nasa supercritical fluid, i-dissolve niya yung dirt. Ganun nila tinatanggal yung caffeine para meron kang decaf coffee. The old ways that they do is what? They put the coffee granules in organic solvent like chloroform, like chloromethane. So malamang may trace pa. But if they do the so-called supercritical fluid extraction, it just removes the target material that they have. So critical point, this is the point on the diagram at which the substance is indistinguishable between liquid and gaseous phase. Kahit taasan mo yung pressure niya or temperature. Now, ito yung tinatawag nating fusion curve, yung between solid and liquid. So it's the one here. And then the vaporization curve, the blue one. And this is the sublimation curve. Okay? Now, an exception nila dito ay yung tinatawag nating water. So tingnan nyo yung curve ng water. Pag ganito, tapos dito, ganyan. At itong klaseng phase diagram ng water makes it unique kasi in most substances, yung density ng solid ay mas mataas kaysa sa density ng liquid. But sa water, it's the other way around. Ano yung prueba nyo? Lumulutang yung ice sa tubig. Which means ice is less dense than water. Okay? So, most likely in the exam, you're given like this one and you're asked to identify what is B. B is what? Your freezing curve. What is C? The line in C here, that is your vaporization curve. Okay, and what is A here? That is your sublimation curve. Or what can you find, or what phase or phases in the B area? Okay. So, try to look at the difference between here. Phase diagram of CO2 and H2O. I think I also have it in my lecture video. Bakit ang tawag natin sa CO2 ay what? Dry ice. Anyone? Why do we call CO2 dry ice? Anyone? It's the same concept as dry cleaning because it doesn't liquefy. When you have a dry ice, from the solid dry ice, it goes right away into a gas. Okay? And the phase diagram has something to do with it. So if you have at atmospheric pressure where it is equals to 1, dalawa lang yung possible na phases pwede mag-exist. Either solid form or liquid form like that. Okay? Hindi siya natutunaw kasi at 1 atmosphere, which is the atmospheric pressure, either solid siya or magsasublime siya agad into gas. But look at water at 1 atmosphere. So anong tawag natin dito? Sa pinupoint ko. Anong tawag natin dito? So ito yung tinatawag nating ano? Anong point yan? Yan yung tinatawag nating melting point or freezing point. Okay? Tapos ito yung tinatawag nating ano? Normal boiling point because it's 1 atmosphere. Okay? So itong letter D, that's the triple point. Anong tawag natin ngayon dito? Sa 218 na yan. Ano yung E? Ganyan yung question ninyo sa exam. What is E? Anong point yan? Anyone? Okay? Yung iba.
Critical point po ba, sir?
Yeah, so that's the critical point. So if that's the critical point, this is the critical pressure and this is the critical temperature. Okay? Now, you can predict the process that happened here. So, pag tinanong kayo, ano yung process from here? Follow yung arrow, ha? Going here. From here, going here. Anong process yun? Or maybe I put it in the drawing para at least makita ninyo. So, I clear this one. So, let's say, so pwede kayong, ano yung process na yan? Let's say that's A. Ano yung process na 2? That's B. Ano yung process na ganito? That's what we call C. Ano yung process na ganito? That's D. So, paano mo ilalagay yun? Sige nga. Ganyan yung mga tanong. So A is what? Melting.
Melting po.
B is the reverse of melting, which is freezing.
Freezing po.
And then C is what?
Sublimation.
Sublimation. And then D is?
Vaporization.
Vaporization po.
Is
Condensation
it
po.
vaporization?
Condensation
po.
Ayan. Ganun yung mga tanong. And ito lang masasabi ko, kung UP student kayo, kuha nyo yan. Kung US student kayo, mahihirapan kayo. Okay? So there are some worksheet that you can work on here. So if you're going to look at here, tagal. So ito yung mga constant temperature and constant pressure transition. So when you say constant pressure, so gaya nito, at 1 atmosphere, so yan, tawag natin freezing point or melting point, ito normal boiling point. Okay, so, ay naku, bakit nawala? Mahina signal ko. There. Teka, baka nandoon pa ako sa isa. Sabi na nga ba eh. Okay, so try nyo i-practice to. So what is T here? T as in T. Triple point. C as in C, which is critical.
critical po.
Okay. Now, if you have a constant pressure transition, so you can do it like this. So pwedeng sa tanongin sa inyo, ano yung phase ng number 1? Or phases? So ano yung 1?
Solid po.
Solid to? What is number 2?
Solid and liquid po.
Solid and liquid. Number 3?
Liquid, sir.
Liquid po.
Liquid. Number 4?
Liquid and gas po.
gas.
Liquid and gas. And number 5?
Gas po.
Gas.
Okay. And then number 6?
Solid po.
And number 7?
Solid and gas po.
Okay. Solid and gas. And number 8?
Gas.
Gas po.
Ganyan yung mga tanong. Ano, ready na kayo? Kaya nyo nang sagutin yan. If you are asked the same question and you are asked what is 1, 2, 3, 4, 5, some sort of.
Slight po.
Sigurado na, hindi siguro. So try to work on these materials. They're there. Okay? Now, when you have constant pressure transition naman, yung ano dito, pwede tanungin nyo yung ano yung phase pa rin. Okay? So for instance here, ano yung number 1? Anong phase yung number 1?
Gas po.
So it's a gas,
Gas
and
po,
then,
sir.
Solid and gas.
Solid and gas po.
okay, and then number 3.
Solid po.
Solid po.
Oh, ito, para kakaiba, number 9.
Ayan.
Number 9.
Gas po.
Gas. Number 10.
Fluid something.
Supercritical
Super
fluid.
critical.
Critical fluid.
Oh, ano, kaya na to.
Kaya po.
So, ito lang yung ano, ganitong style lang magka-question sa inyo. Usually that's a typical one. I have not looked at the exam yet, but if ever I want to test my student, yung mga tanong na ito yung ibibigay sa inyo. And I think you can see it doon sa tawag dito, reviewer that I sent to you. And that's end. Module 5. So, gamitin yung link doon, ha? Kasi yung gagawin ko ngayon is, I try to poll you. Sagutin niyo lahat ng mga tanong dito. Kita niyo ba? Hindi ko naman kilala kung sino yung sumagot. Kaya maging honest kayo. Oh, lahat sila nanonood, lahat helpful. Pero pagdating sa exam, ba't mababa? So, ibig sabihin hindi helpful. O, at least may isang honest, hindi niya tinitingnan yung material sa module. No. Hindi daw helpful yung recorded lecture. Kasi hindi siya nanonood. Kaya ganito yung approach na ginamit ko ngayon. Why do you have to overthink? Hindi nyo naman ikakamatay kung bagsak kayo, di ba? Ganun naman talaga eh. At lalong magle-level up yan. Pustahan tayo, yung lab mas mahirap kaysa sa lecture exam. Right? Kasi, nagturo ako nung time na bago pa lang ako na lab instructor. Ang ginagawa ng lab instructor, pataasan ng ihi sa paggawa ng exam. So, ano mangyayari pag pataasan ng ihi? Mahirap yung question. Di ba? Nung lab instructor pa ako, ang hirap talaga ng lab kaysa sa lecture. To the point na masuntok ko na yung isang kasama kong lab instructor kasi sabi ko, being coordinator, panindigan natin tong question na mahirap. So tinanggap nila. So at least I think out of ilang daan na kumukuha, I think mga 50 lang estudyante ang nakasagot ng tama. Tapos sabi nung nagbigay ng tanong, sana hindi na natin binigay yung question. Parang gusto ko siyang suntukin nung sinabi niya. Sabi ko, bilang coordinator, pinanindigan ko yung question mo tapos ngayon iiwanan mo ako sa ere. So pag nagreklamo, ako yung haharapin ng mga higher ups. Okay? Mahirap talaga lalo na pag face to face. So bakit kayo natatakot kapag online? Dito nga yung ano namin online noon, may proctoring eh. Alam niyo yung proctoring software? So, kumukuha sila ng exam, naka-video. Okay? So, yun lang yung maano ko sa inyo. Practice, practice, practice. So, this weekend, read. Solve. And then, anuhin nyo yung quiz. Ano sabi ko sa inyo? You don't go with the grades. Ano yung kailangan nyo gawin? Ano yung first meeting natin na ano ko sa inyo? Na advice. you go that you're going to learn something and everything will be easier. Okay? You learn to earn your grades. Kasi sabihin ko sa inyo, pag gusto niyo ng grade, talagang irereklamo niyo ako kasi hindi kayo nakakuha ng A. Pero ang tanong ko, may natutunan ba kayo? Okay? Because I told you, as a UP student, ang ano namin doon, there's no such thing as a hard exam. Hindi lang kami nag-aral, kaya mahirap yung exam. But now, if you see, if you utilize the material, what did I tell also? Okay, you have what? The letters in the course is what you need to do. Ginagawa niyo ba yun? Do you do the chemistry? Or sasabihin niyo na lang yung jumbled letters after ng exam? Bakit ako? Christ, why me? Okay ba? May inflation nga no, tinatawag nila sa online. Kasi nga, you have all the notes. But we also have to do about the anxiety. So, bawasan niyo yung anxiety. You might say, oh, is your 7 of siya. Ako nga, minsan nagiinom a night before ng exam. Yun nga lang, yung mababang score ko, nangyari nun. So ano, kaya ba? Kaya nyo nang i-chicken
Yes,
ng
po.
exam? So let's go on the other one kasi hindi ko masyado na ano yung module 4 eh. Nasa na yun. Basta kailangan maintindihan nyo, okay? Tapos pag may tanong doon, maintindihan nyo. And utilize the time. Sabi ko nga sa'yo, nag-aano sila masyado daw mahaba yung 2 hours. Kasi tinignan nila yung overage eh. Yung overage natin, alam nyo kung ano, gano'ng katagal? 1 hour. Kasi namomonitor namin kung gaano kayo katagal sa exam. So let's go on module 4 habang may time pa tayo. So the module 4, I think yung main quiz natin sa module 4 is IMFA. Yun yung talagang naano natin. Ang hindi natin klaro na ano dito, ito. Yung kinetic molecular theory. So yung kinetic molecular theory natin, you share. This is the model that used to describe the behavior of the gas. But you can use it also to describe the behavior when they are in liquid and solid form. Okay? So usually, if you're going to look at this kinetic molecular theory, ang main difference ng gas from the solids and liquid is they don't have the intermolecular forces of attraction. Okay? So in one of my lecture, I explained to you the yung movement nga ng gas, since they don't have an intermolecular forces of attraction, they usually what? Moving at random. And whenever they collide with one another, the collision is what we call elastic. Okay? I'm trying to find the thing here. So, even though model yung KMT nung gas, pwede mo pa rin siya i-apply doon sa liquid and solids kasi gumagalaw pa rin naman yung mga ano doon eh, yung atoms saka molecules. Okay? Sa liquid, they are far from one another, so there's movement that you have. Sa solid, even though they are fixed position. I don't know if you heard the word vibration. So for instance, if you are an ice, yung ulo ko yung oxygen, tapos dalawang kamay ko yung hydrogen, may movement silang ganyan. O di kaya ganun. Yung tinatawag naming stretching, it can be symmetrical or asymmetrical. And that is the basis for the instrument known as IR and Raman. Yung tinatawag naming vibrational spectroscopy. Okay? So you can still apply your kinetic molecular theory in liquid and in solid form. So, ang main difference ng gas doon sa liquids at saka sa solid is the absence of IMFA. Di ba? Ano sa solid? Definite shape, definite, volume. Right? Sa liquid, definite volume but not definite shape. It assumed the shape of the container. Bakit hindi na definite yung shape niya? Kasi they slide with one another because the attractive forces that they have is already what we call less compared doon sa solid phase. Now, when you go to gas, not definite shape, not definite volume, because they're far away from one another. Okay? And then you can also go with what we call the classification of solids here. So ano yung classification ng solids na meron tayo? Metallic, ionic, covalent network, and covalent molecular. So if you have an ionic, meron kang cation tsaka anion. So usually, they have their own properties. Okay? So ionic solids, usually, they have high melting point, high boiling point. They're brittle. They don't conduct electricity unless you dissolve them in water. Anong main reason? Ba't kaya nagka-conduct ng electricity? Anyone? Anong material ang nag-a-allow nun?
Yung valence electrons po.
Okay? It's the electron. Now, in ionic solid, when they're bound, there's no free electron. Unlike in a metal, there's what we call the sea of electrons. Kaya metal, good conductor of heat and electricity. Now, yung ionic solid, once you dissolve it, nagiging available na yung cation and anion. Okay? So ano yung pwedeng itanong sa inyo dito? Ibibigyan kayo ng isang molecule or isang compound and you are asked, what type of solid is this? Okay? You look at my chapter 11 review session, review material and lecture about this one. So, anong pagkakaiba yung covalent molecular solid doon sa covalent network solid? So, usually network solid is intramolecular bond, covalent bond. In covalent molecular solids, ang nag-hold sa kanila together ay yung tinatawag nating IMFA, intermolecular forces of attraction. Okay? Sa metal is metallic bond, sa ionic solid is ionic bond. So if you're going to look at the names that they have there, it has something to do kung ano yung nag-hold sa kanila together. So yung tatlong intra, ionic, metallic, and covalent bond, and the last one is the IMFA. So ito yung, we could say, tingnan nyo. Itong table na to. Do you see a table? May nakikita kayong table? Class?
Yes po.
And then what's the next one? So try nyo itong sagutin. Basta, try lang kayo ng try. Okay? So amorphous and crystalline. I try to see, meron ako nakita, ewan ko kung na ano ko dito sa parang picture or meme, yung difference ng amorphous at yung crystalline. Mais yung picture ng mais. Kasi hindi ko ata makita ngayon. A friend of mine posted it in Facebook. So crystalline, they are highly ordered kontra dun sa amorphous. So dito yung mga type ng tanong na pwedeng itanong sa inyo. Okay? Then properties of liquids. Dalawa lang yan. Viscosity at surface tension. Okay? So yung surface tension is yung ability ng ibang liquid na mag-form as like, ano bang tawag dun? Kita niyo yung water droplets if you put in a wax paper. So nagpo-form siya na parang circle. Compare, let's say, sa kerosene na pag drenap mo sa wax paper, kalat. So what's the difference there? Yung IMFA on water, which is hydrogen bonding, allow it, yung parang pinupul siya sa gitna para at least mag-form siya ng parang droplet. And in addition to this, if the surface is big enough, okay, pwedeng mag-float yung substance. I don't know if you notice it. Try nyo yung sinulid. Ilagay nyo sa tubig. If you form it in this position, the surface tension is strong enough to hold it together. But if you try it in this position, it will just fall. Yan yung reason kung bakit kayang mag-walk ng mga insects sa bodies of water. Or pag meron kayong dahon ng gabi, pag nilagay nyo ng tubig, nakikita nyo yung mga droplets. Nagigets nyo ba yung sinasabi ko? Familiar ba kayo doon?
Yes po.
And the way that surface tension happen is it's stronger if the IMFA is stronger. Now, yung viscosity naman, it has something to do with what? Resistance to flow. So pag meron kayong, wala na si Aunt Jemima dito. So if you have this syrup, so usually, mabagal yung flow niya. And the main reason for that is the network of hydroxyl group or OH group, which makes it a strong hydrogen bonding. Okay? So, nandyan na rin yung tinatawag na capillary action. So, I would like you to look at this. Okay? Kung hindi nyo ma-access yung lecture, you read the materials that are here. Okay? And then, don't forget the different gas law. So, ito yung portion na ibibigay ko sa inyo during the weekend. Okay lang ba sa inyo sa weekend o gusto nyo sa Monday na lang? Let me know. So here, yung gas. Okay? Ano yung property ng gas? Pressure is one of the property. Okay? Tapos, pwede kayong bigyan na ganito, true or false. The gas molecule are in constant motion. The answer is true. So, meron kayong video na dyan, panoorin nyo.
If you're going back to school, before you submit your essays, run it through Grammarly to quickly check for spelling, punctuation, or grammar.
Hey, it's Professor Dave. Let's talk about ideal gases.
He knows a lot about the science stuff.
I use this video also for my students. So they're really what we call helpful. Okay? So you have to know ano yung pagkakaiba no tinatawag nating different noble natural gas. So ideal gas law is applicable at what? Low temperature and high pressure, some sort of. And the ideal gas law results from the different gas law. Yung Avogadro's law, Boyle's law, which is pressure and volume, they are indirectly proportional. Charles law, volume and this what we call absolute temperature. Okay, the Avogadro's law. So this is between the volume and the amount of gas. So when you combine all of them, that's what you get. And I told you doon sa lecture ko, merong ganyan. So anong pagkakaiba ng ideal tsaka sa real gas? So ideal only exists ideally, but the situation that we have is what? Real, di ba? Gusto natin ideal, tall, dark, and handsome. And in reality, ano meron? Tall, dark, and handsome na mukha. Right? So, ask yourself, gusto nyo ba sa weekend or gusto nyo mag-full blast sa weekend and then come Monday, you can have your quiz in preparation doon sa ano natin. But on Tuesday, I have no choice but I have to start equilibrium. And then siguro sa Thursday, babalikan na natin kung handang-handa na kayo. Ano? Let me know in 2 minutes. Tanong. You can show up yourself if you want. Papatayin ko na yung recording.